So, yes, so the essential ones, you can summarize them with private Tim Hall. So what you want to watch out for here is there is more than one amino acid that starts with the letter A. And so just remember that this one is arginine, okay? All the other A's are non-essential, okay? So this one's arginine. Also, with the letter P, there's a couple letter P's. This one is phenylalanine, okay? And then the last thing that you want to remember is you've got a bunch of L's here, but there's one more L. So which one do you not have? And we're going to draw that one over here. In blue. All right. Lysine. And I'm going to make another category here where we call it Conditionally essential. Essential amino acids, AA. All right. So, excuse me. Brain blip. It is not the L, it is the T. All right. We have more T's, and it is tyrosine. Tyrosine. Okay? Now, I'm going to share with you how I just corrected myself. I remember that the conditionally essential are, first off, what are conditionally essential? They are ones that you can make in your body, but only if you have the essential amino acid that they are made out of. Because as soon as you don't have the essential amino acid, well, they become essential because then you can't make them anymore. Okay. All right. So, and the way that I remember the conditionally essential amino acids is titch. Like, I'll be with you in just a titch. All right. So we have T, C, H, H, titch. Okay. And they all are T, Y, C, Y, H, Y, H, Y. Okay, so it's titch and then a bunch of Y's. And that gives you tyrosine, cysteine, whatever. And then hydroxy, lysine, and hydroxyproline. Okay, and all the other guys are non-essential, and we're going to talk about how to make them. Now, really quick, these conditionally essential ones, how do you make them? Well, with hydroxy, lysine, and hydroxyproline, I think we can figure out where those come from. Yep, good. Just lysine and proline. Tyrosine, we saw last Tuesday, comes from phenylalanine. You remember when we had the tire and the funnel at the bottom? And yeah, okay. And it does it using a specific enzyme that we'll get to in a sec. And then cysteine comes from methionine. Okay, and hydroxyproline, I think, actually might be able to be shifted over because proline is not a conditional. So I think you can always make hydroxyproline, but she wanted you to know that there's a special. Someone brought it up, that she brought up hydroxyproline as just, so I'm just going to make it as a note down here in our little notes section. All right. Hydroxyproline exists. Okay. Okay. So it's lysine, which is going to be one of these essential ones. That's for the conditional. Okay. All right. Moving on we then want to know how to make glutamine, glutamate, arginine, aspartate, asparagine aspartate, I should say, and some other things. So we're going to learn those 4 all together, which is great. So we have glutamine. How many nitrogens can glutamine carry?
Two?
Yes.
Okay.
Excellent. And how many can asparagine do?
I believe it's 3.
2.
2.
But you're right that it's more than 1, which is kind of what we're shooting.
Okay.
Aspartate. Okay. Notice that the ones that carry 2 end in "ine."
Okay.
And now these guys share so much that I like to do them together. How do you make? How do you break? In order to make glutamine out of glutamate, you use, oh my gosh, glutamine synthetase. Glutamine synthetase. Okay? So really it's that thing synthetase.
Okay.
And that's how I'm going to write it for this next one. Right here, how do you make asparagine out of aspartate? It's that thing synthetase. So asparagine synthetase. Synthetase. Okay, so they're both that thing synthetase. How do you break them? Okay, well, glutamine to glutamate is going to be it's glutaminase or glutaminase. So it's just that thing ace. And over here, it's, care to take a guess?
Asparaginase?
Yes! Even pronounced it correctly the first time.
Okay.
That thing ace. Asparaginase. Asparginase. Yeah, and that breaks it down to aspartate.
Okay.
Wonderful. And they just throw a nitrogen off into the nether realm. Alright, because that's the difference between the two, is just a nitrogen, right?
Nitrogen, yeah.
Okay, so I'll write a little nitrogen in parentheses off to the side. And that's what's going on. Now, that's 4 of them that we've gotten a lot done. So, next, we would have glutamate. What is its alpha keto acid or carbon skeleton? Both of those mean the same thing. Alpha keto acid, carbon skeleton.
Pyruvate? Why no? Oh man.
It sounds like glutamate and alpha keto acid.
Don't remember.
All right, alpha keto glutarate.
Alpha keto.
Yes. Alpha keto glutarate. And that's all right because there are a lot of amino acids. All right. And aspartate, that one is the one that has all the animals. So another word for donkey is ass.
Right.
All right. And what does that mean that it's going to turn into?
The ox?
Yes.
Oxaloacetate.
Excellent. Oxaloacetate. Or OAA if you want to abbreviate it. Okay. So for the glutamate one, this is the big deal. Like glutamate and glutamine and alpha ketoglutarate are the big deal transporter of all the things from the liver to the kidney, and they do important things. And so we have a lot of nitrogen enzymes for moving nitrogen to the glutamate family, because that's how we get rid of the nitrogen. And if we didn't, and it's much easier to just send glutamine rather than send all 21 amino acids through the blood, and then it's really hard to regulate. So we make them all into the glutamate family and then send them on. So when this one, really quick, glutamate is that thing dehydrogenase. It's glutamate dehydrogenase. And then that's the one that does that. However, and it just goes straight down. But aspartate wants to move its nitrogen most of the time to the glutamate family, because that's what all of them want to do, because glutamate's cool. So aspartate is going to have, this is the one thing that's different. Notice same, basically. This and this, slight difference. Right here we have aspartate transaminase.
Transaminase, okay.
AST. Okay? So, and that's the way that you name a lot of the transaminase. It's, you know, the amino acid transaminase. Okay? And AST is something that you will see in the blood. I'm going to make a little note down here just because AST, it's an enzyme that should never be in the blood.
Mm-hmm.
And so if it's in the blood, that means you popped the cell and you leaked it into the blood. Oh. That means there are cells dying. They're probably muscle or liver cells. And that's kind of like the super extra little tidbit knowledge that'll help you in gen med and all that kind of stuff. That's labs. Mm-hmm. But sneak peek, okay? AST. The other one is ALA, which is alanine transaminase. Muscle, and I can spell muscle, liver. All right, same thing for that. They're both muscle liver. Okay. All right. So what this does is, as we said, it's going to move the nitrogen to the alpha-ketoglutarate, which then makes the alpha-ketoglutarate turn into glutamate. So this is just a nitrogen coming on down, and I'll just draw it in blue because it's like nitrogen going this way. All right. Cool?
Yeah, it's making a lot of sense.
Oh, good. Excellent. So it's just this horseshoe.
Yeah.
All right. So let's go ahead and do a review, okay? First off, what is the acronym for the essential amino acids? We did a lot, so.
Private Tim Hall.
Nailed it.
Okay.
All right, Private Tim Hall, PBT Tim Hall. Now, what did the P stand for? Because we got more than one type of P.
Phenyl.
Good.
Alanine?
Yes,
yeah.
Phenylalanine. And then what did the A stand for?
A is aspartate? Arginine.
So, what I like to think is Private Tim Hall has a colorful black background. Before he went into the military, he was a pirate, but he was a very lame pirate who just fanned the captain. And so he held a giant fan and he was like, "Oh, Captain, my Captain." All right. So, and then he became Private Tim Hall, and he's much more respectable now. Okay. So next, what are the conditional amino acids? And what is their acronym to remember them? I'll see you in just a
touch.
There you go.
Yes. Okay. So that would be the tyrosine.
Good.
Okay. C is.
They all have the same second letter.
Cysteine?
Yes.
Cysteine.
See, you got it.
And hydroxyproline?
Lysine.
Lysine.
Okay. Hydroxylysine.
Hydroxylysine. And then there's also hydroxyproline, but it's, that's to the side.
Yeah, that's FYI.
All right.
Okay, beautiful. Now, close that part of it. You've got that's what we call the general stuff. Now, we're going to go into tyrosine is made out of what?
Tyrosine.
And this is the one where I drew arrows between the two lists.
I remember the tire with the phenyl on it.
Excellent. So what's that?
Phenylalanine?
Yeah, so phenylalanine will turn into tyrosine. And then for the next one down, cysteine.
Cysteine. So that would be lysine.
That one actually is going to come from methionine.
Methionine. Okay. So
Okay, and we'll talk more about those because really I just mentioned them and we're going to go into them in more detail.
Okay.
Now finally, tell me about the top half of the glutamate, glutamine, aspartate, asparagine things. So just the up and down between those. You don't need to do the bottom bit yet.
Okay.
Because all these enzymes match. So we're doing the matching enzymes first.
Matching. Okay. So the top part, they both carry 2 carbons.
Nitrogen.
Nitrogen. Sorry. Nitrogen.
But yes,
Okay.
correct number.
All right. 2, and then you need the whatever it's called synthetase.
Yep.
So glutamate synthetase and I can't pronounce it.
Yeah, but you're right. Asparagine.
Asparagine.
Glutamine and asparagine.
Glutamine and asparagine synthetase.
There you go.
And then to break it, you need the glutamine. No, wait. Yeah, glutamine dehydrogenase.
Just ACE.
ACE.
Glutaminase.
Glutaminase.
So glutamine ACE. If it's ever hard to say glutaminase, because it takes practice, believe me. I said it wrong 4 times today. It's just glutamine ACE, and that's good. So what's the other one?
The same thing, right? It's asparaginase?
Exactly.
Okay.
All right. And now going down to the glutamate and aspartate that want to become something and something. What does glutamate become?
Alpha ketoglutarate.
Bam. And aspartate becomes?
That's I think that's different, right? Okay, so and I think I saw oxaloacetate.
Yes.
But it wants to become a cool guy like glutarate, right?
Yes.
So it needs to go through a what's that enzyme called? Transaminase, but it's a aspartate.
Yes.
Transaminase, yes.
Bingo.
So that's going to become alpha ketoglutarate, and then from there it becomes glutarate.
All right, and so it doesn't become alpha ketoglutarate. I'm glad you said that. It goes and gives its nitrogen to alpha ketoglutarate.
Just say listen.
Yeah. Awesome. So it's just given a nitrogen, and then as soon as you take a nitrogen off of aspartate, you call that, since it now doesn't have a nitrogen, we have to call it something new, even though it looks almost exactly the same. It's oxaloacetate. So the only difference between this molecule and this molecule is a nitrogen.
Okay.
So you're just, and then that makes it into glutamate.
And you still get your oxaloacetate from the aspartate, right?
The oxaloacetate, yep, that's just all the leftover bits of aspartate.
Oh.
So this is the alpha keto acid of aspartate.
So you're making 2 molecules out of that one aspartate.
Alpha ketoglutarate was already there,
Oh, okay.
and so you're just taking the nitrogen off of this guy and putting it onto this guy, and then even though they both look almost exactly the same as they did before, you have to change their name because nitrogen is really important.
Oh, okay.
And so if it has a nitrogen, we change the name.
Got it. Yes.
No nitrogen, call it that. Has a nitrogen, call it that.
All right.
Shibete?
Yeah, I got it. So the alpha ketoglutarate, once it gets the nitrogen, it becomes glutamate.
Yes.
Yeah.
Yep.
Okay.
And if we took and did this reaction in reverse, which is possible, then we could take it away from glutamate and put it onto oxaloacetate and move it back up.
Okay.
So it's just reversible.
Got it.
Okay. Good deal. So those 4 are done. All right.
Yes.
And we'll want to hit them one more time. One more thing that I find really helpful. All these enzymes are named after the top guys. All these enzymes are named after those guys.
Yeah.
And so they're all named after the one that's above them if you draw it this way.
Yeah.
So next we're going to do a nice light one so our brains don't explode. Alright, alanine. Do you know what alanine's alpha keto acid or carbon skeleton is? If I took the nitrogen off of alanine, what would we call it?
Is it pyruvate?
Yes, excellent. Well done.
Yeah.
Alright, so, and we do that with ALA, alanine transaminase. ALA, which is alanine transaminase. And, wait, did I, ALA? No, ALT.
Oh, okay.
Alright, ALT. And we're running a little bit shy on time, so I'm going to write some stuff up and then try to review each box and just be like, okay, take them down one at a time and make sure it's up there.
Yeah.
So I didn't finish all these guys over here, so I'm going to just go ahead and write that this is phenylalanine, so PA, phenylalanine, aka that thing. Hydroxylase. Alright, that's for my benefit because I always want to say something else. Hydroxylase. Okay? That's a hydroxyl group, OH.
Oh, okay.
OH. And so that's how I remember that it's a hydroxyl base. Cysteine from methionine. This one, I'm not going to write an enzyme. This one, I want you to go and look up homocysteine. Why can I always spell it better on this line? Anyway, so homocysteine, methionine will turn into homocysteine, and then homocysteine could either turn back into methionine or it can turn into cysteine. So methionine can change into cysteine by going through the homocysteine pathway. And it's kind of nice that it's homocysteine. Kind of tells you. If you build up a lot of this, it's bad. So we want it to be either of those guys, but not the middle one. We have to make it the middle one to do some important things in the body. And I'm just going to write, you're going to look at this, but B9, folate, and B12 are an important part of making that happen. If you don't have these guys, you have a ton of homocysteine. Okay, so none of him and none of him means lots of him. And that makes it messy, so you don't have to copy that. Alright, moving on really fast. We're going to do, next we have the ornithine proline. Proline comes from glutamate, and glutamate can also become something called ornithine, which is found in the urea cycle. And that's just how it is. Really, I don't think that knowing the enzymes between these two is crucial, but give a once-over. It's in the slides. Okay. This is the bird's eye view. Glutamate can become proline. All right, up over here. Now we're going to talk about two of them at once. There is Sarin and Glycine. And Sarin is the star of this story because he's got more than one way to make him, and we want to talk about all that. But we're going to talk about the first way. How would you make Sarin out of nothing? First, you would take CO2, carbon. This CO2 would give us carbon. And then we're going to take ammonia, NH4, and we add those together, and it makes glycine. And the enzyme is going to be called glycine synthase. There is no extra T. It's just synthase.
So no ATP needed.
Exactly. All right. And then once we've made glycine, there is a glycine serine. It's a methylation reaction. The enzyme I'm going to have you look up because it's like glycine serine. It's SH4 or SH. It's like it goes S and then H and then K, C, and then anyway, there's like 4 words in it, but it's methylation. SHCM? I don't know. Anyway, it's a methylation reaction. Look up the name of the enzyme.
Okay.
That is one way to make serine.
One way. Okay.
And that's also how you make lysine. All of these
Make lysine.
are reversible.
Okay.
Okay? So you can make lysine out of serine. You can make serine out of glycine. You can make nothing out of glycine. You can make nothing turn into glycine. It's not nothing, but... Lastly, from glycolysis. Glycolysis. You can have, there's something called phosphatidyl, it's not phosphatidyl, it's it's 3-phosphoglycerol, or glycerate. 3-phosphoglycerol, something close to that anyway. 3-phosphoglycerol, and this one goes through a bunch of steps. The last one is the one we care about because that's the enzyme that can be broken in a disease, and that is going to be phosphoserine, so PS, phosphatase. Phosphatase. Okay?
Oh, yeah, I found out. Yes, it's a 3-phosphoserine phosphatase.
Yes, 3-phosphoserine. And you'll notice that you can take phospho and serine, and that's where it gets its name, because that's what it's doing. All right, so go ahead and vamp through that, and hopefully it helps.
That helps, thank you.